Hey everyone! Tonight we're embarking on a journey through the universe's grandest architecture. Before we drift into the cosmic depths, take a moment to like this, if these deep space meditations bring you peace, and share in the comments where you're listening from and what time it is in your corner of the world. I'm always moved by how our global community comes together to contemplate the infinite together. Now, settle back. Let those lights fade. Tonight, we're not pursuing dramatic cosmic collisions or searching for alien civilizations. Instead, we're going to explore something far more profound and serene: the slow, graceful dance of galaxy clusters and superclusters across billions of years. Let's begin our gentle voyage into the vast. Imagine floating in the deepest reaches of intergalactic space, surrounded by a profound stillness that has persisted for eons. Here, time moves differently. A million years passes like a single breath. Around you, scattered across the cosmic darkness, gentle points of light drift in an ancient choreography, each one an entire galaxy containing hundreds of billions of stars, yet appearing as mere whispers of luminescence in the infinite black. These are the universe's largest gravitationally bound structures, cosmic cities of galaxies that dwarf our human comprehension. Tonight, we'll explore how these magnificent congregations of light formed from the universe's earliest whispers, how they continue their patient dance across cosmic time, and how their very existence reveals the invisible architecture that shapes all of reality. We'll visit the Virgo cluster, our own cosmic neighborhood, where over 1,000 galaxies gather in a sphere 15 million light-years across. We'll contemplate the Coma Cluster, where dark matter first revealed its mysterious presence to human understanding. We'll journey to the vast Shapley Supercluster, a cosmic continent containing thousands of galaxies across 400 million light-years of space. Each of these structures tells a story of cosmic evolution written across billions of years, of gravity's gentle but inexorable pull, weaving the cosmic web that connects all things. Tonight, we become witnesses to the universe's grandest symphony, played out in movements so slow and vast that entire civilizations could rise and fall between the cosmic notes. In the profound stillness of deep space, where time moves with the gentle patience of eternity itself, we find ourselves contemplating structures so vast that they dwarf not only human comprehension, but the very galaxies that seem infinite to our earthbound perspective. Here, in the cosmic cathedral of the universe, gravity performs its slowest and most magnificent dance, orchestrating the movement of billions of stars across distances that light itself takes millions of years to traverse. The universe reveals its architecture through a hierarchy of breathtaking gentleness, each level of organization nested within the next like cosmic Russian dolls of light and matter. From our small world orbiting a modest star, we peer outward through increasingly vast scales of cosmic structure, each transition marking a profound shift in our understanding of space, time, and our place within the cosmic web. Consider first the gentle gathering we call a galaxy group, where 3 to 50 galaxies drift together in gravitational embrace, their combined mass creating a subtle well in the fabric of space-time. These cosmic neighborhoods exist in peaceful congregation, their member galaxies orbiting slowly around their common center of mass over periods measured in billions of years. The local group, our own galactic neighborhood, exemplifies this intimate scale of cosmic structure, where the Milky Way, Andromeda, and the Triangulum Galaxy along with dozens of smaller companions, perform their ancient gravitational waltz. As we expand our perspective, we encounter the grander assemblages known as galaxy clusters, where 50 to 1,000 galaxies gather in configurations that span millions of light years. These cosmic cities represent some of the largest gravitationally bound structures in the universe, their combined mass so immense that they bend light itself, creating gentle arcs and distortions in the images of more distant galaxies beyond. Within these clusters, hot gas at temperatures of millions of degrees fills the space between galaxies, glowing softly in X-ray wavelengths like cosmic aurora, visible only to our most sensitive space-based telescopes. The historical journey to understanding these vast structures began with gentle observations of fuzzy patches of light in the night sky. Charles Messier, in his methodical cataloguing of celestial objects during the late 18th century, unknowingly documented the first members of what we now recognize as galaxy clusters. His careful observations of nebulous objects, intended to help comet hunters avoid confusion, actually recorded some of the most distant and massive structures visible to telescopes of that era. William Herschel continued this patient work of cosmic cartography, his systematic surveys revealing the true abundance of these mysterious nebulae. Through countless nights of observation, he began to perceive patterns in their distribution, noticing that certain regions of the sky contained unusual concentrations of these fuzzy objects. What Herschel was witnessing, though he could not have known it, were the first hints of the cosmic web's grand architecture. The revolutionary understanding that these nebulae were actually external galaxies, island universes comparable to our own Milky Way, came through Edwin Hubble's patient observations in the 1920s. Using the newly completed Mount Wilson Observatory's 100-inch telescope, Hubble resolved individual stars within these nebulae, measuring their distances and revealing the true scale of the cosmic hierarchy. Each point of light that Messier had catalogued as a nebula was revealed to contain billions of stars, and the clusters of these objects represented congregations of entire galaxies. Fritz Zwicky's groundbreaking work in the 1930s added another layer of mystery to these cosmic structures. Through careful measurements of galaxy velocities within the Coma Cluster, he discovered that the galaxies were moving far too quickly to be held together by the gravitational attraction of their visible matter alone. This led to his proposal of dark matter, an invisible component that provides the additional gravitational binding necessary to hold these massive structures together. The cosmic dance of clusters, it seemed, was choreographed by forces we could not directly observe. Modern astronomy has revealed that beyond galaxy clusters lie even grander structures called superclusters, cosmic continents of light that span hundreds of millions of light years. These vast assemblages represent the largest coherent structures in the universe, collections of galaxy clusters connected by filaments of galaxies that stretch across cosmic time. Unlike the smaller structures within them, superclusters are not gravitationally bound. They represent the transition from structures that gravity can hold together to those that are slowly being pulled apart by the universe's expansion. The contemplation of these cosmic megastructures invites us into a meditation on scale and time that transforms our understanding of existence itself. These are structures that existed long before our solar system formed, their slow gravitational evolution unfolding across timescales that encompass the entire history of complex life on Earth. They remind us that we are not merely observers of the cosmos, but participants in its grand architecture, our atoms forged in the hearts of stars that once danced within these very same cosmic congregations. In the gentle vastness of our cosmic neighborhood, where time moves with the patience of eternity itself, we find ourselves drawn into the contemplative embrace of the Virgo cluster. This magnificent congregation of galaxies serves as our nearest major cosmic community, a gathering so vast and ancient that it existed long before our solar system began its first tentative dance around the young sun. The Virgo cluster stretches across 15 million light-years of space, a distance so profound that light itself, traveling at its cosmic speed limit, takes 15 million years to cross from one edge to the other. Within this immense sphere of gravitational influence, over 1,300 galaxies move in their slow, eternal orbits, each one a complete universe unto itself, containing billions upon billions of stars, planets, and the infinite possibilities they represent. As we drift peacefully through this cosmic neighborhood in our imagination, we can observe the gentle hierarchy that governs these celestial communities. The cluster's heart beats with the rhythm of Messier 87, a giant elliptical galaxy that serves as the gravitational anchor for this entire cosmic congregation. This ancient galaxy, formed when the universe was still young and star formation burned with fierce intensity, now rests in serene maturity, its trillion stars arranged in a smooth, glowing envelope that extends far into the surrounding space. The discovery of the Virgo cluster unfolds like a meditation on human curiosity and patience. In the 1770s and 1780s, Charles Messier, working with his modest telescope under the dark skies of 18th century France, began cataloguing the fuzzy patches of light that appeared in his systematic search for comets. Night after night, he would observe these mysterious nebulae, carefully recording their positions and appearances, not knowing that he was documenting entire galaxies, each containing more stars than grains of sand on all the beaches of Earth. The constellation Virgo became a particular focus of Messier's attention, as it seemed to contain an unusual concentration of these nebulous objects. What he was observing, though he could not have known it at the time, was the central region of our nearest major galaxy cluster, a cosmic city whose citizens were entire galaxies, each one a vast collection of stars, gas, and dark matter, bound together by gravity's gentle but inexorable pull. The true nature of these objects remained hidden for over a century until Edwin Hubble's patient observations in the 1920s revealed that these nebulae were actually island universes, galaxies like our own Milky Way, but separated by distances so vast that their light had traveled for millions of years to reach our telescopes. The Virgo cluster, Hubble realized, was not a collection of nearby gas clouds, but a gathering of galaxies so distant that we were seeing them as they appeared when the Earth was still young, and life was just beginning to stir in the primordial oceans. Today, as we contemplate the Virgo cluster through the eyes of modern astronomy, we can appreciate the profound influence it exerts on our own cosmic neighborhood. The cluster's immense gravitational field, created by the combined mass of all its member galaxies, plus the invisible dark matter that surrounds them, reaches across the cosmic void to gently pull on our local group of galaxies. Our Milky Way, along with the Andromeda Galaxy and the dozens of smaller galaxies that make up our local cosmic family, is slowly falling toward the Virgo cluster at a speed of several hundred kilometers per second. This cosmic journey toward Virgo will take many billions of years to complete, a time scale so vast that it encompasses the entire future evolution of our Sun and the eventual merger of the Milky Way with Andromeda. Yet even across these immense spans of time and space, the gravitational influence of the Virgo cluster continues to shape the motion of our galactic home, demonstrating the interconnected nature of cosmic structure on the largest scales. The cluster itself exists in a state of dynamic equilibrium, its member galaxies orbiting within the gravitational potential well created by the cluster's total mass. Some galaxies follow elliptical orbits that carry them from the cluster's outer regions down toward its dense core and back out again, journeys that take hundreds of millions of years to complete. Others move in more circular paths, maintaining a roughly constant distance from the cluster center as they participate in the slow cosmic dance that has continued for billions of years. Between these galaxies flows a tenuous but incredibly hot gas, the intracluster medium, heated to temperatures of tens of millions of degrees by the gravitational energy released as the cluster formed and evolved. This gas, invisible to our eyes but glowing brilliantly in X-ray wavelengths, fills the space between galaxies like a cosmic atmosphere, its gentle luminosity revealing the cluster's gravitational architecture and the history of its formation. In the depths of space, some 320 million light-years from our own Milky Way, lies a cosmic gathering that first whispered to humanity about the universe's hidden architecture. The Coma Cluster, formerly known as Abell 1656, drifts through the constellation Coma Berenices like a vast congregation of light, its 1,000 galaxies bound together by forces both visible and invisible, dancing to rhythms that span billions of years. This cluster holds a special place in our understanding of the cosmos, for it was here that Fritz Zwicky first glimpsed the universe's greatest mystery. In 1933, working at the California Institute of Technology, this Swiss astronomer turned his attention to the Coma Cluster's gentle assembly of galaxies. What he discovered would fundamentally change our perception of reality itself. As Zwicky measured the velocities of galaxies within the cluster, he found something profoundly puzzling. The galaxies were moving far too quickly for the cluster's visible matter to hold them together. By all calculations based on the light he could observe, these cosmic islands should have long ago dispersed into the surrounding void, scattered like leaves in a cosmic wind. Yet here they remained, bound in their ancient dance, suggesting the presence of something vast and invisible. He called this mysterious component Dunkel Materia, Dungeon dark matter, coining a term that would echo through decades of astronomical research. The Coma Cluster became the first cosmic laboratory where we glimpsed the universe's hidden scaffolding, the invisible framework upon which all visible structure depends. Today, as we contemplate the Coma Cluster through multiple wavelengths of light, we see a structure of breathtaking complexity and beauty. Invisible light, over 1,000 galaxies, populate this cosmic metropolis, their combined luminosity creating a gentle glow that has traveled across hundreds of millions of years to reach our telescopes. These galaxies, predominantly elliptical in shape, appear as soft, golden orbs, their stellar populations aged and settled, having long ago exhausted their star-forming gas in the cluster's dense environment. The cluster spans approximately 20 million light-years, a distance so vast that light itself requires 20 million years to cross from one side to the other. Within this enormous volume, the galaxies move with stately grace, their orbits shaped by the combined gravitational influence of both visible and dark matter. Some galaxies plunge toward the cluster's center, their paths bent by the immense gravitational field, while others trace more leisurely elliptical orbits around the cluster's periphery. When we observe the Coma Cluster through X-ray telescopes, an entirely different realm reveals itself. The space between galaxies, far from being empty, glows with the soft radiance of gas heated to temperatures of 50 million degrees Celsius. This intracluster medium, composed primarily of hydrogen and helium, creates a tenuous atmosphere that permeates the entire cluster. The gas glows in X-rays, revealing the cluster's gravitational potential well, the invisible depression in space-time created by the cluster's enormous mass. This hot gas tells a story of cosmic violence played out over geological timescales. As galaxies fall into the cluster, they experience a process astronomers call RAM pressure stripping. The hot intracluster medium acts like a cosmic wind, gradually removing the cooler gas from infalling galaxies. This process, occurring over hundreds of millions of years, transforms gas-rich spiral galaxies into gas-poor ellipticals, fundamentally altering their character and evolutionary destiny. The Coma Cluster's gravitational field is so powerful that it bends the fabric of space-time itself, creating what Einstein predicted as gravitational lensing. Background galaxies, located billions of light-years beyond the cluster, appear distorted and magnified, their light bent around the cluster's immense mass. These cosmic mirages provide astronomers with a direct method of weighing the cluster, revealing that dark matter comprises approximately 85% of the cluster's total mass. Modern observations have mapped the distribution of this dark matter with unprecedented precision. The invisible component forms a roughly spherical halo centered on the cluster's core, with the visible galaxies embedded within this dark matter scaffolding like cities along an invisible highway system. The dark matter's gravitational influence extends far beyond the visible cluster, reaching out across tens of millions of light years to influence the motions of nearby galaxy groups and isolated galaxies. The cluster's two dominant galaxies, NGC 4874 and NGC 4889, reside near the cluster's center, their positions marking the deepest part of the gravitational potential well. These massive elliptical galaxies, each containing hundreds of billions of stars, represent the end products of countless galactic mergers that occurred as the cluster assembled over cosmic time. Their extended halos of stars, stripped from smaller galaxies during close encounters, create a diffuse glow that traces the cluster's violent formation history. As we contemplate the Coma Cluster's serene appearance in our telescopes, we witness a cosmic meditation on the nature of time and gravity. The cluster's current configuration represents the accumulated effects of gravitational interactions occurring over billions of years. Each galaxy's position and velocity carries information about the cluster's formation history, encoded in the gentle choreography of their orbital dance. The cluster continues to evolve, accreting matter from its surroundings as cosmic expansion brings new galaxies within its gravitational influence. Small galaxy groups approaching from the cluster's outskirts will eventually merge with the main body, adding their stars and dark matter to the cluster's growing mass. This process of hierarchical assembly, predicted by our understanding of cosmic structure formation, continues today at a pace measured in hundreds of millions of years. In the profound stillness of intergalactic space, the Coma Cluster stands as a testament to the universe's hidden architecture, a cosmic laboratory where the interplay between visible and invisible matter creates structures of incomprehensible beauty and complexity, forever dancing to the gentle rhythms of gravity and time. In the vast cathedral of space, where silence reigns supreme and time moves with the patience of eternity itself, there exists a structure so magnificent, so incomprehensibly large, that it challenges our very understanding of what it means to be immense. The Shapley Supercluster stretches across 400 million light-years of space, a cosmic continent of light that contains more than 8,000 galaxies arranged in over 25 separate clusters. Each cluster itself a gathering of hundreds of galaxies bound together by the gentle, persistent pull of gravity. Named after the astronomer Harlow Shapley, who first began to map these distant realms in the early 20th century, this supercluster represents the largest known concentration of matter in our local universe. To comprehend its scale, we must let our minds drift slowly outward from our familiar cosmic neighborhood, past the local group with its handful of galaxies, past the Virgo cluster with its 1,000 galactic members, traveling deeper and deeper into the cosmic web until we encounter this vast congregation of light and matter. The Shapley Supercluster lies approximately 650 million light-years away in the direction of the constellation Centaurus. From our perspective on Earth, it appears as a subtle enhancement in the distribution of galaxies, a gentle brightening in the cosmic tapestry that speaks of immense gravitational forces at work. Yet this apparent subtlety masks a structure of staggering proportions, one whose gravitational influence extends across billions of light years, shaping the very flow of matter through the universe. At the heart of this cosmic continent lies the Centaurus cluster, a massive gathering of galaxies that serves as the supercluster's gravitational anchor. Here, hundreds of galaxies orbit in stately procession around their common center of mass, their movements governed by the same fundamental forces that guide planets around stars, yet operating on scales that dwarf our solar system by factors of trillions. The cluster's central region glows with the soft light of giant elliptical galaxies, cosmic lighthouses that have been shining for billions of years. Their stellar populations evolved and mature, their gas supplies long since exhausted by the cluster's hot, thin atmosphere. Surrounding the Centaurus cluster, other major clusters contribute to the supercluster's immense gravitational field. The Hydra cluster, the Laniakea cluster, and numerous smaller groups of galaxies all participate in this vast gravitational dance, their individual motions contributing to the supercluster's overall structure and evolution. Each cluster tells its own story of cosmic evolution, from the violent early epochs when galaxies first began to congregate, through the gradual accumulation of matter over cosmic time, to the present era of slow, stately orbital motion. The discovery of the Shapley Supercluster's true significance came gradually as astronomers in the 1980s began to map the large-scale distribution of galaxies with unprecedented precision. What they found was not merely a collection of galaxy clusters, but a structure whose gravitational influence extended far beyond its visible boundaries. The supercluster acts as what astronomers call a great attractor, a massive concentration of matter that pulls on surrounding galaxies and galaxy groups, creating flows of matter across hundreds of millions of light years. Our own local group, containing the Milky Way and its neighboring galaxies, participates in this cosmic flow. We are falling gently toward the Shapley Supercluster at a speed of several hundred kilometers per second, a motion that has been ongoing for billions of years and will continue for billions more. This movement is so gradual, so cosmic in its timescale, that it represents no immediate change to our local environment, yet it connects us intimately to this distant congregation of galaxies. The structure of the Shapley Supercluster reveals itself most clearly when viewed through the lens of large-scale galaxy surveys. Modern telescopes have mapped the positions and velocities of thousands of galaxies in this region, revealing a complex web of filaments and walls that connect the various cluster components. These filaments, streams of galaxies extending across tens of millions of light-years, represent the cosmic web's architecture on the largest scales, showing how matter has organized itself under the influence of gravity and dark matter over the universe's 14 billion-year history. Within this vast structure, individual galaxies pursue their ancient orbits with a serenity that speaks to the fundamental stability of cosmic architecture. A spiral galaxy falling into one of the supercluster's component clusters will experience a gradual transformation over hundreds of millions of years, its star formation slowly quenched by the hot intra-cluster medium, its spiral arms eventually fading as it evolves into a more elliptical form. This process, known as galaxy harassment, occurs with such geological slowness that it represents a kind of cosmic meditation on the nature of change and permanence. The Shapley supercluster's influence extends beyond its immediate vicinity through its role in shaping the cosmic web. Computer simulations of structure formation show how such massive concentrations of matter create the scaffolding upon which smaller structures form and evolve. The supercluster's gravitational field helps channel matter along filaments, creating the highways along which galaxies migrate and clusters grow. In this way, the supercluster participates in the universe's ongoing evolution, serving as both a destination for cosmic flows and a source of gravitational influence that shapes the surrounding cosmic landscape. In the depths of space, some 400 million light-years from our quiet corner of the cosmos, lies a gathering so vast and luminous that it defies our earthbound comprehension. The Perseus cluster unfolds before us like a cosmic symphony, its gentle melodies written not in sound waves that travel through air, but in the profound harmonics of X-ray radiation, flowing through the thin, impossibly hot gas that fills the spaces between galaxies. Here, in this serene congregation of over 1,000 galaxies, we encounter one of the universe's most remarkable phenomena, the actual sound of cosmic evolution itself, propagating through a medium so rarefied that each cubic centimeter contains fewer particles than the best vacuum we can create on Earth, yet so vast that these whisper-thin gases stretch across millions of light-years, creating the perfect cosmic instrument for nature's grandest compositions. The Perseus cluster reveals itself most beautifully to our X-ray telescopes, which peer through the darkness to show us the gentle glow of gas heated to temperatures of 50 million degrees Celsius. This is not the violent heat of stellar cores, but rather the peaceful warmth that emerges when gravity performs its slow, patient work across cosmic time, drawing matter together with such inexorable gentleness that the very act of assembly creates this magnificent thermal embrace. At the heart of this cosmic gathering sits NGC 1275, a galaxy of extraordinary character that serves as both the cluster's gravitational anchor and its most active participant in the ongoing dance of cosmic evolution. This central galaxy, also known as Perseus A, harbors within its core a supermassive black hole that feeds with remarkable restraint, neither dormant nor violently active, but maintaining a steady, gentle consumption that has continued for hundreds of millions of years. The black hole's feeding process creates jets of particles that stream outward at nearly the speed of light, but rather than destroying or disrupting the surrounding environment, These jets perform a delicate cosmic choreography. They carve graceful cavities in the hot intracluster gas, creating bubbles and ripples that propagate outward like the gentlest of cosmic weather systems. Their influence felt across distances that span entire galactic neighborhoods. It was here, in this peaceful assembly of galaxies, that astronomers first detected something that seemed impossible: actual sound waves moving through the cosmos. These are not the rapid vibrations we associate with earthly sounds, but rather pressure waves with wavelengths measured in thousands of light years, oscillations so slow and vast that a single wave cycle takes tens of millions of years to complete. The discovery emerged from the patient observations of the Chandra X-ray Observatory, which revealed subtle variations in the temperature and density of the hot gas surrounding NGC 1275. These variations formed concentric patterns, like ripples on a cosmic pond, each ring representing a pressure wave that had been propagating through the cluster medium for millions of years. The waves move at the stately pace of cosmic sound, about 500 kilometers per second, carrying with them the gentle signature of the central galaxy's long-term activity. These cosmic sound waves represent the lowest notes ever detected in the universe, vibrating at frequencies nearly 60 octaves below middle C on a piano. If we could somehow hear these cosmic melodies, they would resonate with a depth and richness that encompasses the entire history of the cluster's evolution, each wave carrying information about the delicate balance between gravitational attraction and thermal pressure that has shaped this cosmic community for billions of years. The Perseus cluster's X-ray glow reveals intricate structures that speak to the gentle complexity of cosmic evolution. Temperature maps show regions where the gas is slightly cooler, creating cosmic weather patterns that shift and flow over timescales of millions of years. These temperature variations trace the history of the cluster's formation, marking the locations where smaller galaxy groups have merged with the main cluster, each merger leaving its thermal signature in the surrounding medium. Within this vast, hot atmosphere, individual galaxies move like luminous islands, their own gravitational fields creating gentle disturbances in the surrounding gas. As these galaxies orbit through the cluster's gravitational field, they experience a cosmic headwind that gradually strips away their own gas reservoirs, a process so gradual and peaceful that it unfolds over hundreds of millions of years, slowly transforming spiral galaxies into the smooth elliptical forms that populate the cluster's core. The Perseus cluster serves as a cosmic laboratory where we can observe the fundamental processes that shape galaxy evolution across cosmic time. Here, the interplay between gravity, gas dynamics, and stellar formation creates a complex ecosystem where each component influences the others in an intricate dance of cosmic feedback. The central black hole's gentle feeding prevents the hot gas from cooling too rapidly, while the cluster's gravitational field shepherds galaxies through their evolutionary transformations with patient, inexorable force. As we contemplate this magnificent cosmic symphony, we find ourselves witnesses to processes that began when the universe was less than half its current age, when the first galaxy groups began their slow gravitational dance toward eventual merger and assembly. The Perseus cluster represents the accumulated result of billions of years of cosmic evolution, a testament to the universe's ability to create structures of breathtaking beauty and complexity through the simple, patient application of fundamental physical laws. As we drift through the vast expanses of cosmic space, contemplating the gentle hierarchies of galaxy clusters and the peaceful dance of their constituent galaxies, we begin to perceive an even grander architecture emerging from the darkness. Like a vast neural network spanning the observable universe, filaments of light stretch across billions of light years, connecting distant clusters in a web of cosmic magnificence that speaks to the deepest organizing principles of existence itself. The cosmic web represents the universe's fundamental architecture, a structure so vast and intricate that it challenges our ability to comprehend scale while simultaneously offering profound peace through its gentle, inevitable patterns. These filaments of galaxies, each containing billions of stars, stretch across distances that light itself requires hundreds of millions of years to traverse, creating pathways of matter and energy that have guided cosmic evolution since the universe's earliest epochs. In the profound stillness of intergalactic space, we can observe how galaxy clusters form like luminous pearls strung along these cosmic filaments, their positions determined by the slow accumulation of dark matter over billions of years. The intersections of these filaments become the sites where the most massive galaxy clusters gather, their gravitational embrace drawing in hundreds or thousands of galaxies into slowly rotating, gravitationally bound communities that will persist for countless cosmic ages. The discovery of this cosmic web emerged gradually through decades of patient observation and theoretical contemplation. In the 1970s, astronomers began to notice that galaxies were not distributed randomly across the sky, but seemed to follow subtle patterns, clustering along invisible pathways that suggested some underlying structure. The first major revelation came in 1989 with the discovery of the CFA Great Wall, a structure containing thousands of galaxies stretching across 500 million light-years of space, revealing that the universe possessed organization on scales previously unimaginable. As we float peacefully through this cosmic architecture, we can observe how the web's structure reflects the universe's earliest moments, when tiny quantum fluctuations in the primordial cosmos were stretched and amplified by cosmic inflation. These gentle variations in density became the seeds from which all cosmic structure would eventually grow, dark matter gathering along the densest regions to form the invisible scaffolding upon which galaxies would later condense like dew, forming on spider webs in the early morning light. The filaments themselves are not empty corridors, but contain vast streams of gas and dark matter flowing along their lengths, feeding the growth of galaxy clusters at their intersections. This cosmic circulation system operates on timescales so vast that entire stellar generations are born and die, while matter slowly migrates along these pathways, creating a gentle but persistent flow that has shaped the universe's evolution for over 13 billion years. Between these luminous filaments lie the cosmic voids, vast regions of space where galaxies are sparse and the density of matter falls far below the cosmic average. These voids, some spanning hundreds of millions of light-years, represent the universe's most peaceful regions, where the gentle expansion of space itself dominates over the gravitational pull of distant matter concentrations. Within these cosmic deserts, the few galaxies that do exist often display unique characteristics, their evolution proceeding in relative isolation from the environmental influences that shape their counterparts in denser regions. The Sloan Great Wall, discovered in the early 2000s, revealed an even more magnificent structure stretching across 1.4 billion light-years, demonstrating that the cosmic web operates on scales that approach the limits of the observable universe itself. This structure, containing tens of thousands of galaxies arranged in a complex pattern of filaments and clusters offers a humbling perspective on humanity's place within the cosmic hierarchy, while simultaneously providing deep peace through its demonstration of the universe's inherent order and beauty. Modern surveys continue to map this cosmic web with increasing precision, revealing how its structure has evolved over cosmic time. In the early universe, the web was more uniform and less defined, but as billions of years passed, gravitational forces slowly sculpted it into the intricate pattern we observe today. This evolution continues even now, with galaxy clusters slowly growing through the accretion of matter, flowing along filamentary pathways, their masses increasing as they draw in gas, dark matter, and occasional smaller galaxy groups. The cosmic web also serves as a laboratory for understanding the nature of dark matter and dark energy, those mysterious components that comprise the vast majority of the universe's contents. The web's structure provides crucial evidence for dark matter's existence, as the visible galaxies trace the underlying dark matter distribution, revealing how this invisible substance has shaped cosmic evolution through its gravitational influence alone. As we contemplate this vast architecture of light and darkness, we find ourselves part of a cosmic address that extends from our small planet through increasingly grand scales of organization. Our local group of galaxies lies within a filament that connects to the Virgo cluster, which in turn participates in the even larger structure of the Laniakea Supercluster, itself merely one node in the infinite web that spans the observable universe. In the vast theater of cosmic time, where billions of years pass like gentle seasons, galaxy clusters perform their slow dance of evolution and transformation. These immense congregations of galaxies, bound together by gravity's patient embrace, undergo changes so gradual that entire civilizations could rise and fall between the smallest perceptible shifts in their cosmic choreography. The formation of galaxy clusters represents one of the universe's most majestic processes, unfolding across timescales that dwarf human comprehension. In the early universe, when the cosmos was younger and denser, tiny fluctuations in the distribution of dark matter began their slow gravitational collapse. Like gentle whirlpools forming in a cosmic ocean, these regions gradually accumulated matter, growing ever more massive as eons passed. What began as subtle variations in density evolved into the magnificent structures we observe today, each cluster containing the mass of thousands of galaxies. The hierarchical nature of cluster formation mirrors the patient construction of a vast cosmic cathedral. Small groups of galaxies merge to form larger groups, which in turn combine to create clusters, and clusters themselves can merge to form even more massive structures. This process, known as hierarchical merging, continues today, though at a much more leisurely pace than in the universe's energetic youth. Each merger event unfolds over hundreds of millions of years, a cosmic ballet performed on scales that render human timescales virtually instantaneous. When two galaxy clusters approach each other across the cosmic void, their interaction creates some of the most spectacular phenomena in the universe. The gravitational dance begins long before the clusters actually meet, as their mutual attraction gradually accelerates their approach. Dark matter halos, invisible scaffolding that holds each cluster together, begin to distort and stretch under the influence of their partner's gravity. The hot gas that fills the space between galaxies in each cluster starts to compress and heat, creating shock waves that propagate through the intra-cluster medium like ripples in a cosmic pond. The famous Bullet Cluster provides a magnificent example of this cosmic choreography frozen in time. Here, two galaxy clusters have recently passed through each other, their collision creating a natural laboratory for studying dark matter and cluster dynamics. The hot gas from both clusters, glowing brilliantly in X-rays, has been stripped away and left behind, while the galaxies themselves and their associated dark matter halos have continued onward, carried by their momentum through the collision. This separation of ordinary matter from dark matter provides compelling evidence for dark matter's existence, painted across the cosmic canvas in hues of X-ray light. The environmental effects of cluster membership profoundly influence the evolution of individual galaxies within these massive structures. As galaxies fall into clusters, they encounter the hot, dense intracluster medium, which acts like a cosmic headwind, stripping away their own gas reservoirs through a process called ram pressure stripping. This gentle but inexorable process transforms gas-rich spiral galaxies into gas-poor elliptical galaxies over hundreds of millions of years, fundamentally altering their ability to form new stars. Galaxy harassment, another environmental effect, occurs when galaxies pass close to one another within the cluster environment. The gravitational interactions during these encounters can trigger bursts of star formation, distort galaxy shapes, and even completely disrupt smaller galaxies. The debris from these disrupted galaxies often ends up forming a diffuse glow of stars throughout the cluster, creating what astronomers call intracluster light, a faint stellar halo that traces the cluster's gravitational potential. The timescales involved in cluster evolution inspire profound contemplation about the nature of change and permanence in the universe. While human civilizations measure their existence in thousands of years, and even our species' entire evolutionary history spans only millions of years, galaxy clusters have been evolving for billions of years. The clusters we observe today began forming when the universe was less than half its current age, and they will continue evolving long after our sun has exhausted its nuclear fuel and faded to a white dwarf. Modern computer simulations allow us to witness this cosmic evolution in compressed time, watching billions of years of cluster formation unfold in minutes. These numerical experiments reveal the intricate details of how dark matter halos grow through mergers, how gas flows and shocks propagate through the intracluster medium, and how galaxy populations evolve in response to their changing environment. The simulations show us that cluster formation is not a smooth, steady process, but rather a series of discrete merger events, each leaving its signature in the cluster's structure and dynamics. The study of cluster evolution also provides insights into the fundamental nature of dark matter itself. The way clusters merge and evolve depends critically on the properties of dark matter particles, and detailed observations of cluster mergers can constrain theoretical models of what dark matter might be. The separation of dark matter from ordinary matter in cluster collisions, like the bullet cluster, provides some of the strongest evidence that dark matter consists of particles that interact gravitationally, but not electromagnetically. As we contemplate these vast cosmic processes, we gain perspective on our own place in the universe's grand narrative. The galaxy clusters we observe today are the products of cosmic evolution spanning nearly the entire history of the universe. They represent the largest gravitationally bound structures in the cosmos, monuments to the patient work of gravity across cosmic time. In their slow dance of evolution and merger, they remind us that the universe is not static, but dynamic, constantly changing and evolving on scales far beyond our everyday experience. The peaceful majesty of cluster evolution, unfolding across billions of years with the stately grace of cosmic time, offers a profound meditation on the nature of change, growth, and transformation in the universe. In their slow dance across the cosmic stage, these magnificent structures embody the universe's capacity for creating beauty and complexity through the simple action of gravity across vast expanses of space and time. As our journey through the vast architecture of the universe draws to its gentle close, we find ourselves floating peacefully in the infinite expanse of cosmic understanding. We have traveled together through the serene hierarchy of cosmic structure, from our quiet Earth to the grandest superclusters, witnessing the slow, eternal dance of matter and energy across billions of years. Let yourself settle now into the profound tranquility of this cosmic perspective. Feel the gentle rhythm of your breathing, synchronize with the ancient pulses of the universe itself. Each breath connects you to the same fundamental forces that bind galaxies into clusters, clusters into superclusters, and superclusters into the magnificent cosmic web that stretches across all of space and time. In the Virgo cluster, we discovered our cosmic neighborhood, where 1,300 galaxies drift in their slow, gravitational waltz. Feel that same gentle motion now, as if you too are floating peacefully among these island universes, carried by invisible currents of dark matter through the warm, glowing medium between the stars. The timescales here are so vast, so profoundly peaceful, that entire civilizations could rise and fall in what amounts to a single moment in the cluster's eternal dance. We journeyed to the Coma Cluster, where Fritz Zwicky first glimpsed the invisible scaffolding of dark matter that holds our universe together. Let this mystery embrace you now like a soft, cosmic blanket. The dark matter that shapes the largest structures in the universe flows through you, around you, connecting you to every distant galaxy in an invisible web of gravitational harmony. You are part of this ancient structure, woven into the very fabric of space-time itself. In the Shapley Supercluster, we witnessed the largest known concentration of matter in our local universe, a cosmic continent of light spanning 400 million light-years. Imagine yourself now as a gentle traveler through this vast realm, moving slowly through filaments of galaxies that stretch beyond all human comprehension. The great attractor calls softly to distant galaxies, and you too can feel its pull, not as a force of disruption, but as a cosmic invitation to rest in the fundamental unity of all things. The Perseus cluster sang to us with sound waves that ripple through million-degree gas, creating cosmic music with wavelengths measured in thousands of light years. Listen now to that same cosmic symphony, playing at frequencies far below human hearing, but felt in the deepest parts of your being. These are the lullabies of the universe itself, the gentle songs that have been playing since the first galaxy clusters formed in the cosmic dawn. We explored the cosmic web, that magnificent architecture of filaments and voids that gives structure to everything we see. Feel yourself now as part of this web, connected to every distant supercluster by invisible threads of gravitational influence. Your breath, your heartbeat, your very existence participates in this grand cosmic dance that began nearly 14 billion years ago and will continue for trillions of years to come. The slow mergers of galaxy clusters revealed to us the patient timescales of cosmic evolution. Rest now in the knowledge that change in the universe happens with such gentle slowness that it brings only peace. Mountains of galaxies take hundreds of millions of years to pass through each other, creating no violence, only the quiet transformation that comes with the passage of cosmic time. As we traced our cosmic address from Earth to the observable universe, we discovered our place in the Laniakea Supercluster, our true cosmic home. Feel the comfort of knowing your place in this vast hierarchy. You are held gently by Earth's gravity. Earth is held by the Sun by the Milky Way by the local group by Virgo, and Virgo by the vast, nurturing embrace of Laniakea itself. Let your mind drift now through these cosmic scales, feeling smaller and smaller, yet more and more connected to the infinite. The galaxy clusters continue their ancient dance. The superclusters maintain their patient vigil, and the cosmic web stretches its gentle filaments across the universe. All is well. All is peaceful. All is exactly as it should be. In this cosmic perspective, all earthly concerns fade into the background like distant stars. You are part of something so vast, so ancient, so profoundly peaceful that nothing can disturb your deep connection to the universe itself. The same forces that shaped the first galaxy clusters are working within you now, creating the same patterns of beauty and harmony on every scale of existence. Rest now in the cosmic web of dark matter, supported by invisible forces that have held the universe together since the beginning of time. Let the gentle motion of galaxy clusters carry you into the deepest peace, where time moves with the slow patience of cosmic evolution, and every moment stretches into eternity. Sleep now, cosmic traveler, held gently in the vast embrace of the universe itself, where galaxy clusters dance their eternal dance, and all is peace, all is harmony, all is one.